Hi everyone, this is the video for Graphs section 4. In this video, I'll give an overview of the section, I'll then go through the worksheet and finally I will answer the questions that are on the worksheet. The description box below gives a link to my Instagram page. On here you can find images of the worksheet and answer sheet and other bits and bobs. So parallel lines are lines that have the same gradient. You can visualise them as lines that never meet, like they just ghost each other. And you can also visualise them as lines that are continuously the same distance apart. If you think of the top of this video and the bottom of this video as lines, then these are examples of parallel lines. They have the same gradient, they're always an equal distance apart, and they, if extended to infinity, will never meet. Perpendicular lines, on the other hand, love a meet up. They will always cross, and where they cross, they form a right angle. And their gradients, if multiplied together, always give -1. So looking at this video again, if you look at this side of the video and the bottom of the video and imagine them as lines, then these two are examples of perpendicular lines because they meet in this corner here, and where they meet they form a right angle, i.e. 90 degrees. So in this video we're going to look at properties of parallel and perpendicular lines, and I'm going to go over a few examples of questions that you might get at GCSE level to do with these topics. So let's get into it.
Right, this is the worksheet for Graphs section 4 on parallel lines and perpendicular lines. As I said in the intro, parallel lines are lines that have the same gradient. This means that parallel lines are lines that are always the same distance apart. It also means that parallel lines never meet. Now that's the case for now. If you were to study mathematics to A level or university, I can't remember which level, you might find out that in some geometries, yes, because there are multiple geometries, parallel lines do meet. But for your learning now, you can just assume that parallel lines never meet. So here's an example of two parallel lines, this blue one and this purple one. And these are the equations for these parallel lines. Now, from our previous sections on graphs, you'll know that this number in front of the x, or this x coefficient, tells us what the gradient of this straight line is. As you can see, both of these lines have a gradient of 2. And this is what I was saying. Parallel lines have the same gradient, and you can see it here. They both have a gradient of 2. So overall, if someone was to ask you if two lines are parallel, all you have to do is show that both lines have exactly the same gradient. Let's go through some examples of questions that you might get that involve parallel lines. Right, let's look at this example here. Find the equation of the straight line that passes through the point -3, 1 and is parallel to the line y equals -3x plus 9. Well, the first thing I always do is remind myself of the equation of a straight line, because what we're trying to do here is find the equation of a certain line. So let's just start out with the generic straight line equation. So there we go. The equation of a straight line is y is equal to mx plus c, where m is the gradient and c is the y-intercept. Right, what does the question tell us? It tells us that this line that we're trying to find passes through this point here and is parallel to this point here. What I like to do first is find the gradient, i.e. I use this knowledge here that the line we're trying to find is parallel to this line. So we know that if the line we're trying to find is parallel to that line, then our line must have the same gradient as that line. And remember, the gradient of a straight line is this number in front of the x. So -3 is the gradient of this line, and because our line that we're trying to find is parallel to it, our line must have the same gradient, i.e. this m must equal -3. So there we go, I've written it down. So our equation was this, y equals mx plus c, but now we know the value of m. So our equation is now y equals -3x plus c. Therefore, the last thing we've got to find is the y-intercept, which is c. Going back to our question, there's always little bits of information that we can use, and the next bit of information to use is that our straight line passes through this point, -3, 1. What that tells us is that when this little x here in our equation is equal to -3, this y here is equal to 1. So what we do is we can plug these values of x and y from this point into our equation and then rearrange to find the value of c. So here we go. The line passes through the point minus 3, 1. Substituting the values of x and y, we get 1 is equal to bracketed minus 3 times minus 3 plus c. How we've got to this is we've taken this equation here. We've gone, y is equal to 1, so we can put a 1 here, substitute a 1 there. And we know this x here is equal to minus 3, so we can put a minus 3 here. So this thing becomes minus 3 times by minus 3. And that's how we get to this point here. So we get 1 is equal to bracketed minus 3 times by minus 3 plus c. So this becomes 1 is equal to 9 plus c. You take the 9 across to the other side of the equal sign and we get 1 minus 9 is equal to c. Therefore, c is equal to minus 8. Now that we know c, we can plug it back into our equation and we can find the equation of the straight line. So this is the answer. This line here is parallel to this line here, and this line passes through this point. So this is the answer to the question. Right, let's have a look at perpendicular lines. So perpendicular lines are lines that, unlike parallel lines, always meet. And when they meet, they form a right angle. When I say right angle, I mean an angle of 90 degrees. So this angle here, and you'll usually see it written with this little box here, and this declares that this angle is 90 degrees. So if two lines are perpendicular, their gradients, when multiplied together, will always equal minus 1. This is always the case, and it's how you check that two lines are perpendicular. So definitely put that in your brain. If you want to show that two lines are perpendicular, you take the gradient of both lines, you multiply those gradients together, and if your answer is minus 1, then you've proved that those lines are perpendicular. So let's just look at an example of this. If we go back to our graph here, and we've got this orange line here, given by this equation, and we've got this green line here, given by this equation. Now, these lines look perpendicular. I would be pretty confident this angle here is 90 degrees. However, in order to prove it, in order to check that these lines are perpendicular, what we'd have to do is take the gradient of this line and the gradient of this line, multiplying them together and make sure our answer is equal to minus 1. So what is the gradient of this orange line? The gradient is the number in front of the x. It's minus 2.5. And what is the gradient of this line? The number in front of the x is 0.4. If you times minus 2.5 by 0.4, the answer is minus 1. Therefore, this proves that this green line and this orange line are perpendicular. I've actually written these workings just down here. Gradient of the green line, m1, because I've put a little 1 here to show that it's the gradient of the first line that I'm working with. m1 is 0.4. Gradient of the orange line, m2, is equal to minus 2.5. m1 times by m2, you put it in your calculator and it gives you minus 1. So it proves that these lines are perpendicular. Right, what about a question that's similar to the one above that we had with parallel lines, but it's dealing with perpendicular lines? This question says, find the equation of the straight line that passes through the point 4, minus 3 and is perpendicular to the purple line on the chart above. So perpendicular to this purple line here. Well, again, I use the same method as we did before. We're trying to find the equation of a straight line. So first thing I do is I write down what the equation of a generic straight line is. And we know from previous topics that it is y is equal to mx plus c. Now again, the next thing I like to do is find the m, i.e. find the gradient. And we look back at our question and we get the information that we need. So to find m, we know that this line is perpendicular to the purple line on the chart above. And we know that perpendicular lines, when their gradients are multiplied together, is equal to minus 1. So we know that this m here, when multiplied by the gradient of this purple line, we will get minus 1. So what do we do? Well, let's look. Let's see what the gradient of the purple line is. The gradient of this purple line is 2. Right, okay. And we know that our line's gradient is m. if these lines are to be perpendicular, 2 times by m must equal minus 1. Therefore, m must equal minus a half, because 2 times by minus a half is minus 1. You can write that as an equation to work out and rearrange if you want, but sometimes it's easy just to see in your head or quickly do on your calculator. So everything I've just said is here. The line is perpendicular to y equals 2x minus 2, which is this equation for this purple line. So m is equal to minus a half, because 2, which is the gradient of the purple line, times by m, which is the gradient of the line we're trying to find, 2 times by minus half is equal to minus 1. Therefore, now we know m, our equation up here becomes y is equal to minus a half x plus c. So now, all we need to do with this is find what c is. Going back to our question, we have a bit more information. We know that this straight line passes through this point here. So we can use these values of x and y in this point, substitute them into our equation, rearrange and find out what c is. And here we go. This y becomes minus 3, which is there, and this x becomes 4, which is there. So this equation reads minus 3 is equal to bracketed minus a half times by 4 plus c. So this becomes minus 3 is equal to minus 2 plus c. You bring the minus 2 across and you get minus 3 plus 2 is equal to c. So c is equal to minus 1. Therefore, the equation of the line we've been trying to find is this. Y is equal to minus half x minus 1. This line passes through the point 4 and minus 3 and is perpendicular to this purple line here. Okay, that's everything I wanted to go over in this section. Remember, parallel lines are lines that have the same gradient. Perpendicular lines are lines whose gradients, when multiplied together, give minus 1. That's literally all you need to know. Once you know that, you can manipulate the maths, you can use that information to find the answer. So I think this is a good point to test your knowledge on parallel and perpendicular lines by answering these questions here. You can either go to my Instagram account and just see the answer sheet there, or you can continue watching this video and you can see me work out each one of these questions so you can check your answers to my answers and your workings to my workings. Thanks for watching.